So this is my 6.4 data analysis done by Alex Colmer. So for 6.1 this was the notational analysis, and this is the data analysis of the group rebounding for offensive and defensive rebounds versus the player's height. So as you can see for the group, there is a player height versus offensive and defensive rebounds. So generally, you would think that the taller players are more likely to get rebounds. But as you can see, not necessarily the taller players get the most rebounds all the time. Sometimes it's like the less taller players will get more rebounds than other taller players than them. But yeah, as you can see in that one. So for offensive rebounds, the p-value is 0.1, which is significant because it's below 0.05. Whereas for the defensive rebounds, the p-value is 0.084, which isn't significant. So clearly you can see that it was a much better reading for defensive rebounds versus defensive rebounds. And here is my comparison of Aaron and Charlie's defensive rebounds. So as you can see, in the first half, Charlie had 1 rebound, whereas Aaron didn't have any. So for a power forward, Charlie would be a lot better because they're expected to get rebounds, and Charlie got the rebounds, so he would be a lot better. Whereas in the second half, they are very equal because they both got 1 rebound each, and so they'll both be competing for the power forward position in that second half for defensive rebounds. Overall, Charlie had 2 rebounds, Aaron had 1 defensive rebound, so Charlie would be better suited for the power forward position. But for offensive rebounds, as you can see in the first half, neither of them got any rebounds. That's not good going towards their power forward position. It's not good at all. Whereas in the second half, both of them got 1 rebound. So overall, Charlie got 3 rebounds and Aaron only got 2. So Charlie would be a lot better suited to the power forward position in a basketball game because they're expected to get a lot more rebounds. So Charlie would be a lot better for that. As you can see here, what is also good for a power forward is that they can make their mid-range jump shots. And as you can see that Aaron attempted 5, made 2, which is good. It's 40%, which is really, really good. But Charlie here attempted 2 and made 2, which is 100%, which is a little bit better. So here, Charlie would also be suited to the power forward position here. And here I'm going to say my strengths and weaknesses for Aaron. So some of his strengths were his 2 points attempted and made, but his weaknesses was definitely his offensive and defensive rebound. So for his strengths, Aaron is primarily a shooter. That's what he's known for, and this can be seen because Aaron shot 7 from 10 mid-range, which is 70%, and 2 from 3, which is 66% from 3-point range, and contributed to 90% of his team's points, which is really, really good and helped his team get the game and get the win. But his rebound isn't that great. So that will affect how many points off rebounds his team can get. So I will so say he got 2 rebounds during the whole game. So next game I want him to get at least 5 defensive rebounds and 3 offensive rebounds, and I will get Aaron to do this by doing the Iron Man drill, which is 5 spots. So he stands at get him to stand at 5 spots, and I'll throw the ball off the backboard, and he has to keep rebounding it for a minute at each spot until, so that will progress his ability to rebound and get everything done that way. So this is my 6.2, which is the technical model, and I'm going to be comparing Aaron and Charlie again for this one. So for the preparation phase, you can clearly see that Aaron makes good contact with his partner, Charles, and stays with him for the preparation phase, whereas Charlie doesn't make that good contact, and you can see that he's making it's easier for George to get round Charlie, whereas for Charles it's a lot harder. So it would be better if Charlie would improve on this. And for the execution, you can see that Aaron had very good execution. He kept his defender behind him and kept him out of the way of the ball, which is very, very good. But he left a bit too early, which could lead to Charles being able to get round him and get the rebound. Whereas Charlie also left too early, and you can see that George could have easily got past him because there was a bit of space. So they could have kept there waited until the ball dropped and then got the rebound. So in the recovery phase, both of them did this one very well. They caught the ball off the rebound and then kept the ball above their head, so it's a lot harder for it to get stolen off them, and turn to face the outlet and pass the ball off to them. So both of them, did really well in the recovery phase. So for Aaron, his strengths was his preparation phase, but his weakness was his execution phase. So Aaron's box out was very good, and he keeps the player back until he needs to get the rebound. But Aaron left too early, which allowed Charles to have time to get the ball before Aaron, resulting in the opposition getting the ball. It would be easy for them to get round and then get the ball. So I'll get Aaron to do the delay drill, which consists of a ball being placed from a certain distance from two players. One player will have, say, a minute or 30 seconds to try and get round the player, to box out the player and stop the other player from getting the ball before that time is up. So that will help. If he does this correctly, it will help him massively with his boxing out. And so those are the ways I will try and get Aaron to improve in his boxing out. So here you can see this is the group data for the numerical model. So this is when we went to university and did all our jump, propulsive impulse and all that. So you can see that the average or median of the group was 780 centimeters. That was their height, and their average mass was 64. So that could easily contribute to their average jumping height, which was 0.41. But you can clearly see that here, with 1.37, with Jacob, that is an anomaly, so it's a less trustworthy set of data. So if I were to do this again, or when I use these results, I would take Jacob out of the equation, so that they're a lot more reliable and I'll be able to use them a lot more. And here I did some R and P values of these, the jump height versus height and some other ones with and without Jacob in it. So here you can clearly see that the p-value is 0.819, which is very, very unreliable, and the r-value is 0.06, which is a slight positive correlation because it's above 0. But this is very, very wrong because here there is Jacob's jump height in it, so it's a lot harder for him. it's a lot harder to get like reliable sources with that being in there. So here I've taken Jacob out, and you can clearly see that the p-value is a lot smaller and the r-value is a lot more reliable. So here it's a lot more reliable with Jacob's jump height out of the equation, and it's more reliable, and I'll be able to use it a lot easier. And so as you can see here, that Charlie had a higher jump height than Aaron in all angles and the countermeasure jump, and had a higher propulsive impulse. And this could have been because of the stretch shortening cycle, which happens, like say, if you were to hit your knee, if you were to hit the patella tendon, it would stretch stretch the muscle spindles in your quads, and the muscle spindles detect a change in range of motion and extent of contraction in your muscles. So when the quads are stretched, when the muscle spindles are stretched, they send a muscle back to the motor neuron in your spinal cord, which happens monosynaptically and activates the motor neurons which go back into your quads and makes the whole thing contract. So when you're doing it in a vertical jump, it acts like an elastic band, so it will expand quickly and then contract. But if you hold it for a long time, the length in muscle will change, meaning that you won't have as much power as if you were to quickly go up and down in that vertical jump. As you can clearly see from Aaron's 90-degree jump height, I remember he was standing in that position, that 90-degree position, for a long period of time, waiting for them to get that perfect angle. So that would have changed the range in muscles and made it a lot harder for him to go back up with as much power as he needed to. So as you can see, the propulsive impulse of Aaron's was a lot lower, so that must have been why. Whereas Charlie was in it for wasn't in it for as long, so they didn't have much time to change. So he had a lot more power when going upwards. Whereas in the countermeasure jump, where you go up and down pretty much instantly, within like a few seconds, up and down, Aaron had much higher than his 45 and 90 degree, where he was down in that position for a short period of time. And so the strengths and weaknesses of Aaron, his strength was obviously his height, so because he was taller than most people when playing the basketball game, so it was easier for him to get rebounds and everything. But his weakness is clearly his jump height. So what I'm going to get Aaron to do when I see him next is get him to get his plyometrics done, so he can work on the power output of his legs, his quads, and the power output of his quads, so he can get a much bigger jump height, and which will allow him to get loads more rebounds, loads more boards, whatever, which will allow him to be a much more efficient power forward, and then he'll be a much better player, and he'll get a lot better. So yeah, that's my 6.4 data analysis by Alex Colmer of my two clients, my two participants, Aaron and Charlie. Thank you for watching. Bye.